In the next problem, we have to apply the formula of tan inverse A plus tan inverse B in the first two terms. On getting the result, we need to apply tan inverse A minus tan inverse B. Let's have a look. The first two expressions on simplification would give me tan inverse A plus tan inverse B. The answer comes out to be tan inverse of 27 over 11. We need to subtract from that tan inverse of 8 over 19. We need to again apply the formula of tan inverse A minus tan inverse B, which gives me the final value of 1. Tan inverse 1 gives me pi by 4. Simple problem, but this tests our knowledge of the different formulas that are there in the syllabus. So be very well conversant with the formulas. I would suggest you to write and practice these problems over and over so that there are no surprises during the exam. Let's go on to the next problem. In this problem, we need to prove that these three sum added to be pi by 2. Now, we know that cot inverse 1 can be written as tan inverse 1. Cot inverse 2 can be written as tan inverse half. And cot inverse 3 can be written as tan inverse 1 by 3. Now, we'll just apply the formula over these two terms and we'll try to achieve at a state such that this sum can be solved real quick. Remember the formula? If you simplify the bracket, you will get a value of 1. So we get tan inverse 1. So the question would become now tan inverse 1 plus tan inverse 1. The value of each tan inverse 1 is equal to pi by 4. 2 times pi by 4 is pi by 2. In this particular problem, we need to prove that tan inverse 2 plus tan inverse 3 is 3 times pi by 4. Now tan inverse 2 plus tan inverse 3 will be tan inverse x plus y by 1 minus xy. Putting the values, we get tan inverse 5 by minus 5, which is tan inverse minus 1. Now this is where the trick in the question lies. We got a value of tan inverse of minus 1. It is tempting to put the value as minus pi by 4. And we have to acknowledge that this value is also correct. But let's have a look at the question once. In terms of principal values, I totally agree that the value will be minus pi by 4. But we have two terms on the screen, both of which are acute angles which are less than 90 degree. Now two acute angles added together has to be an angle which is either acute or obtuse. It can definitely not be a negative angle. Hence, the sum of two acute angles will be 3 pi by 4 and not minus pi by 2. Minus pi by 4 would be correct and accepted if we were looking for a principal value. But in this case, it's a general solution and the answer is 3 pi by 4. Please make a note of this particular problem as well. In this particular problem, we need to solve 4 terms and check that the sum is pi by 4. The best way of doing it is take 2 terms at a time and apply tan inverse A plus tan inverse B between the 2 terms. So the first 2 term gives us tan inverse of 12 by 34. The second 2 terms give us tan inverse 11 by 23. Now the result should be used in such a manner that we can apply tan inverse A plus tan inverse B. On simplifying, we get tan inverse of 1. We very well understand that it is equal to pi by 4. A little lengthy as a problem, but quite a good one for practice. Let's move on to our next problem. In this problem, we have sin inverse 1 by root 5 plus sin inverse 2 by root 5 and we need to prove it as pi by 2. In order to solve this, we need to apply the formula of sin inverse A plus sin inverse B, which is sin inverse x plus sin inverse y is equal to sin inverse x times root over 1 minus y square plus y times root over 1 minus x square. Now simply putting the value of x and y into the expression, we would get sin inverse 1, which is pi by 2. The next problem would be application of cos inverse A plus cos inverse B. Now, in order to solve this, we need to use the formula cos inverse x plus cos inverse y is cos inverse of xy minus root over 1 minus x square times root over 1 minus y square. Putting the values, we get cos inverse of 13 by 65. It would be 33 by 65, okay? Next this is an important one again. This time we have cos inverse of 3 by 5 plus sin inverse of 12 by 13. In order to solve this problem, we have to convert either cos inverse to sin inverse or sin inverse into cos inverse. In this particular problem, it is better to convert cos inverse into sin inverse as the answer is in terms of sin inverse theta. To solve that, we have cos inverse 3 by 5 can be written as sin inverse root over 1 minus 3 by 5 whole square, which happens to be sin inverse of 4 by 5. Now, the question therefore becomes sin inverse 4 by 5 plus sin inverse 12 by 13. On applying the formula of sin inverse A plus sin inverse B, we get sin inverse of 56 over 65. The particular problem is important because we first need to convert cos inverse into sin inverse and then need to apply the formula. Let's go on to the next one. This time we have tan inverse 1 by 3 plus sec inverse of root 5 by 2. In order to solve this problem, we first need to convert sec inverse into tan inverse. Sec inverse x can be written as tan inverse of root over x square minus 1. Putting this into the problem, we get the second term becomes tan inverse of half. Now we need to simplify tan inverse 1 by 3 plus tan inverse half. The value comes out to be tan inverse of 1, which is pi by 4. Again, important problem because we are first converting sec inverse to tan inverse and then applying the formula of tan inverse A plus tan inverse B. Let's go on to the next one. In this problem, we have tan inverse 4 by 5 added to tan inverse 3 by 5. So as you remember, we first need to convert cos inverse into tan inverse. How would we do that? Cos inverse into tan inverse can be done by the help of method of triangles. This is 4, this is 5, as we are talking about cos theta. Using Pythagoras theorem, the perpendicular becomes 3. So converting into tan inverse, we get tan inverse 3 by 4. So my question becomes tan inverse 3 by 4 plus tan inverse 3 by 5. Applying the formula, we get tan inverse of 27 over 11. In this problem, we have cosine inverse 5 by root 41 and cot inverse 4 by 5. Similar problem, the answer needs to be proved as pi by 2. So first we need to convert either of them into a known quantity. I would suggest converting cot inverse 4 by 5 into sine inverse or cos inverse for that matter. So let us take this. This was cot inverse of 4 by 5. Using Pythagoras theorem, it would be 16 plus 25 and that is 41. So it becomes root 41. It would also be written as cos inverse of 4 by root 41. On adding these two and applying the formula, we would get cos inverse of 0 and that is pi by 2. We can also convert both into cot inverse or both into tan inverse as well. In this problem, we have to simplify the term sin inverse 4 by 5 plus cos inverse 2 by root 5 and prove it is equal to cot inverse of 2 by 11. Step 1, we would need to convert sin inverse term into cos inverse. So on doing so, sin inverse 4 by 5 becomes cos inverse 3 by 5. Remember the formula? Sin inverse of 4 by 5 can be written as cos inverse of, which is cos inverse of 3 by 5. So this and this added together can be simplified using the formula cos inverse A plus cos inverse B. On simplifying, we get cos inverse of 2 by 5 root 5. Now our answer has to be in terms of cot inverse. So applying our concept of triangles, we note that the base is 2 and the hypotenuse is 5 root 5. On finding the perpendicular, we get 125 minus 4, that is 121, and the square root of that, which is 11. So my final answer in terms of cot inverse would be 2 over 11. I hope friends you like the video. So if you like the video, please share it with your friends, share it with your teammates, your classmates, subscribe the channel, and see you next time. Good day.